Alrighty, so let's look at 6.3. This section is all about the graph of these exponential functions, the different pieces, some descriptions. So the first question we have here about these exponential functions is, what is the domain? Exponential functions in general will look something like a j either going upward, or we could see something with a j moving downward. So we can have growth or decay. For this growth or decay, the domain doesn't matter. The domain for these functions is going to be all real numbers. And that's pretty much true for all of the graphs that we will be working with. So just remember all real numbers for a domain. The range will depend on if we have growth or decay. You can kind of see here with growth, my y value, I kind of stop at 0. Nothing's happening below that 0. So if it's growth, it's going to be greater than 0. And if we have a decay, we're going to be less than 0. Again, this 0 line kind of cuts it off. So if I'm looking at this function here, to tell whether or not we have growth or decay, we look at our rate, right? Because we have the form a times b to the x, where b is our rate. Is that rate greater than 1? Well, yeah, 2 is greater than 1, so this is increasing, which means our range will be everything greater than 0 for this problem. Intercepts are when x equals 0. So all I have to do for this function is replace x with 0. And guess what? These are the best problems ever. Doesn't matter what the number is on the inside. Anything raised to the 0 power is 1. So we have our intercept at the point 0, 1. Then this next one, we want to know if our graph is increasing or decreasing. So we look at our rate here. We want to ask ourselves, is 4 or 5 bigger than 1 or smaller than 1? If you struggle, this would be where I'd use a calculator and make it into a decimal and just do 4 divided by 5. You get 0.8. 0.8 is definitely less than 1, so this would be decreasing or decaying. We have another intercept question. So again, we want to replace all those x's with zeros. -2, 1/2 to the 0. So we start off with our rate, our fraction here. Anything raised to the 0 power, well, it's just going to be 1. We leave what's out in front, and guess what? You do that multiplication. 1 times anything is just the number in front. So our initial value here is -2. So we'd have the point 0, -2. i.e., what you're looking for with these problems when it talks about intercept is you are looking for a. So this is another just way to think about it. This is my y-intercept. So you don't even have to put in 0, just know that part. And my last one here, what is the point on the graph? F of x equals 2 over 3 when x equals 1. So we're just being asked here to replace our x with 1. So 2 over 3 to the first power. Well, you can do this in a calculator, but anything raised to the first power, this would just be 2 over 3 times 1, i.e., it's still just 2 over 3. So the point here would be 1, 2 over 3. For our point on this graph. Which means with these problems, as we get into graphing, what I recommend doing, plug in 0 to get one point and plug in 1 to get the other point. Okay? So in this function, right, we're being asked, what is the function here if we had to write it? When you're writing your function, you can always start off with f of x equals. If you remember, I just said this is our y-intercept, right? So where is it at y? Well, this point looks like the point 0, comma 3, which means my A here is equal to 3. This would be something where it's a multiple choice question. You might be able to get rid of some choices. So always use that to your advantage. After that, we want to find our rate. And this is where things might get a little bit trickier. What you're going to want to do here is find another point. So what do we have here? We have 0, 3. It looks like I have the point 1, 5, if I am reading this correctly. Let me double check that. Oh, it's 1, 6. So this might be a little bit tricky to picture. Obviously, I just screwed it up, but we have 1 here. If I go straight up from 1, it does look like I hit the 6, not the 5. So that would be my fault. So you also have the point 1, 6. With these problems, what I'd recommend doing is kind of making a table if you need to. So you went 0, 3, 1, 6. So I have those points. The question is, what times 3 will equal 6? The answer there is obviously 2, which means my rate here would be times 2 to the x. So it's just a matter of looking very closely, zooming on the graphs. If you have issues with any of the graphs, please let me know. Number 8, it says we have the graph of 2 times 0.7 to the x. What is the point on the graph when x equals 1? You could try to read the graph. This might be where I'd recommend plugging it in just to be more sure of your answer. So what we would have here is 2 times 0.7, and I'm replacing x with 1. Anything to the first power is just that number, so I have 2 times 0.7 still, so this would be 0.4, which probably makes some sense. It looks like we're not quite at 2 there, but it's really hard to read when you're getting decimal answers, so I'd recommend plugging those in. And we have multiple choice, okay? Again, we want to try to read these as best as possible. So this says, what is the for what value of x does f of x equal 1? So f of x is the same thing as y. So I want my height to be 1. So that would be this line. It looks like that's hitting about there. That value of x looks to be -5. So some of these are about reading these questions and making sure you fully understand. And now we want to figure out what function is this graph being pictured here. So I would always start off with your A. What is our initial value? It's this point where I'm crossing here. So once again, we have point 0, 3. So if I was writing this, I'd have f of x equal to 3 times something to the x is what I'm expecting. And that can help me break this down, right? If I'm looking at this has 0.2. That D definitely can't be the answer. I don't see my 3. It should be 3 times something. 3 is my initial value, not my rate. This has 2 in the front, not 3. So without even doing the rate, I'm pretty sure I already know my answer. Other things that kind of give this away is this function is decaying, which means I should expect to have some type of decimal rate in here, which that 0.1 does check that box as well. If we tried to find another point, it might be very difficult with this picture, honestly, so I think this is the best way to do this problem. So use the information at hand. Some of them, they might actually give you the decimals. Again, if you're having issues reading it, please let me know. And I will see you guys in class.